when we think about solutioning and finding global partners to solution
Hello, viewers. Greetings to you and welcome to my live broadcast. Please let me know where you're watching from. If you have any question, you can drop your question. When I'm through, I will attend to the questions. Now we have what is called load analysis table. The load analysis table will aid you, in properly sizing a solar power system, because if you have a client or you have some loads that you want to power with your solar system, you need to take each of the individual power rating of those loads. Then you look at their runtime hours, look at their power rating, and from there you'll be able to calculate, you'll be able to size the inverter, size the solar panels, size the battery bank, and from there you can also size the information you have from your load analysis table. You size the cables, the breakers, and also size your charge controller. So if you have loads, different loads, and you want to properly size that solar power system, it is good for you to prepare a load analysis table. It will make the work very easy for you. And the calculation, sizing the various components of a solar power system will not be, difficult. So this is how to prepare a load analysis table. You draw the table like this. Sorry. The first one here is SN, the serial number. Then the next one is description. This is the second row. Description. Then the next row, the next column, you have a quantity. Then you move to the next one, you have power. This is in watts. Then you have total power. Also in watts. Then you have runtime. This one is in hours. Please, if you are just joining, thanks for joining my live stream. Please let me know where you're watching from. Then the next one, we have total energy consumption or daily energy consumption. This one is in watts hour. So this is the load analysis table, and these are the things you are going to write there. The first column, serial number. Second, description. Third, quantity, power, total power in watts, the runtime in hours, and the total energy consumption in watts hour. Now we take the first one. The description here is the kind of load or appliance you want to use. So let's take the first one. Maybe we have television, and we have two pieces, and their power rating is 50 watts. So to get the total power, you multiply this quantity by power. So it will be 50 multiplied by 2. So this will be 100 watts. So let's assume we are using this TV for 5 hours. For 5 hours, you multiply the total power by the runtime hours. So let's assume we are using the TV for 5 hours. We're using it for 5 hours. What would be the total power? The total daily energy consumption. So let's assume this is 5 hours. So we now multiply 100 by 5 to get our total daily energy consumption. So it will be 100 multiplied by 5. This will be 500 watts hour. So you can see that the first one, we have television. This is our television, and there are 2 in number. Their power rating, their individual power rating is 50 watts each. Then their total power is 50 multiplied by 2, which is 100. Then we have the runtime hours. We want to make use of these 2 televisions for 5 hours every day. They will be on for 5 hours. So to know the total daily energy consumption, you multiply the total power by the runtime, which is 100 multiplied by 5 to give us 500 watts hour. Then we go to number 2. Let's say we have a decoder, and it is 1. The power rating of this decoder, let's say it is 15 watts, and the total power will still be 15 watts, 15 multiplied by 1. And we're also using it for 5 hours. So it will be 15 multiplied by 5 to give us 75 watts hour. Then we move to the next one, number 3. Let's say we have a blender, or let's take another one. We have light bulbs. We have our LED bulbs. LED bulbs, and let's say there are 6 in number. And since they are LED, their power rating is 5 watts. So what will be their total wattage? It will be 5 multiplied by 6 to give us 30 watts. And we are using them for 4 hours every day. So it will now be 30 multiplied by 4 to give us 120 watts hour. So this is how to prepare a load analysis table. You can continue. You continue. If you have other appliances, other loads that you want to add, you continue. Now, when you are through with all the loads that you need, you want to use this solar power system to power. Now, when you are through, you only need to take into consideration these 2 parameters, the total power here and the total daily energy consumption. You have the total power and the total daily energy consumption. The total power here is what you will use to size your inverter. Then the total daily energy consumption is what you will use to size the battery bank and also your solar panels. So if we have here 1 plus 15 plus 30 will give us, here we have 145 watts. Now, when you're through, you're going to sum this column, this total power and total energy consumption. You're going to sum them. 100 plus 15 plus 30 will give us 145 watts. Then for the watt hour, we are going to sum everything in this column. So we'll have 500 plus this 75 plus this 120. So this will give us 695 watts hour. This is in watts and this is in watts hour. The essence of this energy, this load analysis table is that if you look at this table, you see that all the appliances, you are not using them at the same time. You are not using them. There's the runtime hours is not the same. For the television is 5 hours, the decoder is 5 hours, but your bulbs, you are using them for only 4 hours. You may have another one, maybe a blender, you are using it for just 30 minutes. You have your home theater, you may be using it for just 4 hours or 6 hours. You have ceiling fan, you have standing fan, and other appliances, their runtime hours may not be the same. So this load analysis table will help you to bring all of them together like this one now, you sum them, you sum this total power to have 145 watts. It's giving you the total power rating of all the loads that you have. This one is giving you total daily energy consumption of all these loads. So these two parameters are the ones you're going to use to size the inverter. Here you size your battery bank, your solar panels. Then from your solar panels, you'll be able to size your charge controller and the cables from the solar panels to the charge controller, from the charge controller to your battery bank. So it is very, very important for you to know how to prepare a load analysis table, because if you don't know how to prepare the load analysis table, you will make the work, your calculations will be very difficult for you. Please, if you have any question, drop your question so that I can attend to the question. Anyone you don't understand, please let me know. And also, please let me know where you're watching from, where you're watching my live stream from. I can't see the charts here, sorry. Okay. We have Mr. Richard is watching from Zambia. Mr. Peter is watching from Ibadan. Mr. Kinte, you're watching from Gambia. Mr. Devans, are you asking a question? That's variable time load. You're watching from India. Mr. Amostik, you're watching from Kano State in Nigeria. And Mr. Devans, you're watching from India. Thanks for joining my live stream. Please drop your questions. If you have your questions, please drop them so that I can attend to them. I can see your chats here now. Please drop your questions. So okay, Mr. Isaac, you said, I must say I must say I love your channel and I'm watching from Enugu State. Thank you. That is Nigeria, the eastern part of Nigeria. Mr. Gbenga Bayode, you're watching from Ibadan. That is Oyo State from in Nigeria. So please drop your questions. So if you have a client, as you're going to the client's house, go with your jotter and with your biro. You sit with your client. Now, as a solar installer, it is always good you educate your client. That is why many solar installations or many solar systems are having issues. And some will come up and tell you that solar will not function during rainy season. When it is raining throughout the rainy season, your solar will not be functioning well. You have to educate your client and let him know everything about solar. So you sit one-on-one with your client and let him know all these things. Ask him, how many appliances, where many of them have issues is maybe in a hotel. You want to install a solar system in a hotel. Remember, in the hotel, you have water heaters. Some of them are rated at 3,000 watts, and you're having like 100 or 200 rooms. It means you're having about 100 to 200 water heaters. And if you're having 500 guests, you're having 50 guests. It means if in the morning, all of them will want to rush to make use of those water heaters, you know the power they will be drawing. Then you have air conditioners. You have other heavy appliances. So you must educate that client that if you want to use solar to power all these appliances, this is what it will cost you. And this is the calculation. But if you want to save cost again, you can incorporate a generator. Then during the day when the solar is on, they can use other appliances, but in the night when the sun is not available, and you can switch to your either power from the grid or switch to your generator. So you need to talk with your client, educate the client. You sit with him. I have 5 television. How many hours are you going to use this television, sir? Oma, the person will tell you, you jot it down. What is the power rating of this television? Now, if you don't know the power rating of the television, you can look at the back of that television. There's what we call a nameplate or a specification sheet. It will give you the power rating of that television. But if you are not sure, as an installer, you need to have an energy meter. A small, is portable energy meter. Once you go to that client's house and you are not sure of that power rating, it's just for you to connect that connect the load to the energy meter, and it will give you the power rating of that load. You can leave the energy meter there for some days. It will give you from there you have an idea of the average daily energy consumption of that load. With this, if you size a solar system after taking these steps, it will be difficult for that solar system to fail unless the client decides to use it otherwise, outside your instructions and the guidance, the guidelines you have given to him. So these are some of the reasons why you need this load analysis table. You need to carry out a load audit to know the total power consumption of your client's load, and you have an idea of the energy consumption of that client. How many the total what's it called, the total daily energy consumption that client is using. So we have Mr. Amos Tigboni. Seriously, I love watching your channel. Oh, I'm grateful. Thanks very, very much. I'm very happy to hear this from you. Mr. Isaac Fame, please, sir, can you do a detailed video on how the connections are done using 48-volt system? How the connections are done using a 48-volt system. Okay, I will try something on that. I love your teaching, watching from Sierra Leone. Thanks very much, Mr. Jeremiah Safai Komende. You're watching from Sierra Leone. Thanks for joining my live stream. I'm very grateful. So Mr. Isaac Fame is saying we should do a detailed video on how the connections are done using a 48-volt system. This one, the energy consumption is small. You can use a 12-volt system, or a 12-volt system will be okay. So if I'm to do a detailed video on a 48-volt system, it means I will increase this load, and even the energy consumption will increase. Now, if your daily energy consumption is high, it's good you use a higher voltage system. Use 48 volts, because that will make you to use smaller size of cables as compared to using, if you use a 12-volt system, the cable size will be large. From the solar panels to your controller to your battery bank, you'll be having large cable size, mostly if you are using a PWM charge controller. Now, the cables also between the battery bank and the inverter, if it is a 12-volt inverter, will also be large. And it will not be too good, because if you are using large cables, large breakers, size of breakers and fuses, you are increasing the overall cost of that system. So you look at the daily energy consumption. Even if it is not too much, like this one is 695 watts hour, you can use a 12-volt system. If you have up to 2000, maybe 18, 19, you can use 24 volts. You know, between 2000, 3000, maybe highest 3005, you can use 48 volts. But for me, anything from 4000, I make use of 48 volts. It makes the system to be easier for me to operate. Even 35, there are some I use 48 volts. You know, even your battery bank size will not be big. But if you're having high energy, daily energy consumption, and you're using 12 volts, your battery size will be big. Mr. Best Value TV, thanks for your efforts in educating us without holding back. I'm one of your customers. Wow, I'm grateful. Thanks very much for joining my live stream. I'm grateful. So like I said earlier, if you look at this table, we don't have refrigerator, we don't have freezer, we don't have air conditioner. These are loads that have motors, like the normal AC air conditioner. That is not the inverter AC. They have what is called starting power or surge power. Now, if you have those kind of loads, that is why it is good for you to always go to that place with your energy meter or watt meter. If you have a refrigerator and you connect it to that watt meter, you look at the power draw. You see it will last for just a few seconds. Once you switch on that load, you see a high amount of power. You can set it to either power or current. You see the high amount of power or current that load is drawing. So from there, you have an idea of the size of inverter you're going to use. For example, this is 145 watts, the total power rating. Now, if you go and get, maybe you have a freezer here, the normal running, some freezers, they are normal running power. Some is just 200 watts, some 150 watts, some 250 watts. But their starting power, most of them will draw up to 1,000 watts, some up to 1,500 watts, some even draw up to 2,000 watts. So it means if you go and carry an inverter that is rated maybe 500 watts or 300 watts, it will not be able to handle that starting power. So if you connect that that refrigerator to the inverter, once you switch it on, the inverter will shut down. It's telling you that the load is higher than its maximum carrying capacity. So even when you're buying inverters, if you look at the specifications of these modern inverters, there's what they always write there. They will tell you the starting power of that inverter. The inverter may be rated at 3,000 watts, maybe a 3,000 watt inverter, but the manufacturer will tell you that this inverter is capable of starting a 1 horsepower water pump or starting a load that is up to 6,000 watts. Remember that this such power will not last for long, may last for some milliseconds, some few seconds. Once it starts, you see it running at its normal power, but it needs that power, that high amount of power or current to start. So you need to take into consideration that starting power, else the inverter will fail. It will not be able to carry that load. So an inverter may be 3,000 watts, but you will see starting power or such power. It will tell you this inverter is capable of handling a such power or starting power of up to 6,000 watts or 6,500 watts. Now, if you go to the battery bank side, if you look at that load, you see the high amount of current that load is drawing. So if your battery bank is not able to withstand that current at that few seconds, the battery bank will also fail. The inverter will sense low voltage, because as it's trying to drag or to draw that power, the battery bank cannot supply that power. So cannot supply that energy, cannot supply that starting current. You will see the inverter will shut down and it will tell you low voltage. So these are the few things, basic things you need to take into consideration when sizing a solar power system. They are very common, but they can mess up your solar installation, they can mess up your work, and they will be giving you a lot of issues. That is why anything you are connecting to a solar power system, take pains to look at the power rating of that load. No matter how small it is, there are some that are small, but they are mighty. Their power consumption is very high. You think the device is just a small device, but by the time you connect it, you see the amount of current or amount of power that small device is drawing. So always take pains to look at the power rating of that load. It will help you in properly sizing a system that will be able to power those loads. Mr. Erastus Ogbonna, you're watching from Cameroon. Thank you for joining my live stream. We have Amostic Boni. I saw solar inverter was connected to car battery charger. The car battery charger was directly connected to the battery, same point with the inverter. Car battery charger. Now, be very careful when you are using external chargers to charge your battery bank. You know that the solar charge controller controls the charging of the batteries and also the discharging of the batteries. If you connect a DC load to the charge controller, it will control the charging and discharging of the battery at the same time. Now, we also have inverters that are hybrid. They have inbuilt charge controllers, and they can also use power from the grid or the generator to charge the batteries. These solar battery chargers, they are designed in such a way that they will properly charge the battery bank, charge it in a very good way that it will not destroy the battery. And they have about 3 steps of charging: absorbent, float charge, bulk charge, and we also have equalization charge. It happens once in a while. The charge controller will try to equalize the voltage, the charging of all the battery banks so that they will be at the same level, they will be at the same voltage. So if you're using any other charger, an external charger, make sure it is rated to charge. It will be able to efficiently charge your solar batteries. It will have these 3 steps of charging: float charge, absorbent charge, and bulk charge. It is always written there. There are chargers. There are external chargers you can buy. We have them in 12 volts, 24 volts, or 48 volts. But the normal chargers they are using to charge car batteries, their power draw is just they will charging the battery even when they are full. Some of them don't have control. That even when the batteries is full, that charger will still be pushing high current, high voltage to the battery. And when you touch that battery, it will become very hot, which is dangerous for your batteries. Anytime you're charging or discharging the batteries and it becomes too hot, it means there's a problem in that battery bank. It's not good for the temperature of a battery to be high, that the battery will become very hot. It is not good for your battery bank. So always look at that charger if it can handle the charging of your deep. Remember, we have car batteries. Car batteries are different from deep cycle batteries. That is why we don't use car batteries for solar installations. We only use deep cycle batteries. So if you want to charge a deep cycle batteries, there are chargers that are meant for that. If you go and use a charger that has constant charging, even when the battery is full, it will not detect that the battery is full to stop sending high current, high voltage to the battery. It will kill the cells of your batteries. Mr. Richard, I'm planning to buy a battery, but I'm having a challenge on the type of the battery to buy between RB battery and gel battery. Which will you recommend for me to buy? We have gel battery, we have sealed battery, we have flooded batteries, we have lithium batteries. All of them are good depending on your system configuration, what you want to use them for, and the connection, and also your energy demand. If you're using lithium battery, you can discharge it up to 80%. If you're using flooded, it's not good for you to discharge it up to 80 or 100%. If you're using sealed, the recommended DOD is always 50% because their own discharge rate is different from if you discharge, you recharge, you discharge, you recharge. If you're deeply discharging them, they will, die fast. So I don't know in your country, the products, you look at the manufacturer, you look at the track record of that manufacturer, they are high quality batteries. But if you are going for high quality batteries, they are expensive as compared to the cheap ones. So if you're going into solar, you should know that you need good cash so that you can buy good components. When you don't buy good components and you install the system, it will be failing. And that is where it will look as if solar is disappointing or solar is not working well. No, most times the components you are using, they are not good. They are not high quality components. So depending from where you are in your country, you check the list or the good quality batteries. Like here in Nigeria, we have what's it called? We have Luminox, we have Deca, and other good brands. There are other good brands that you can make use of. Then Mr. Value TV, you said I just had 100 amps 12 volt recently installed, mainly for my laptop, but it seems something is not right somewhere. I will reach you via WhatsApp. No problem, no issues. You can always contact me. If you look at my channel description, you will see my WhatsApp link. Just click it. Go to my channel description. You see my WhatsApp link. Click it there. You can chat me up on WhatsApp. Thanks, Mr. Value TV. I'll be expecting your chat, and I'll be also very grateful to help you fix the problem. Then Mr. Orin's Concepts. Hello, sir. I joined in late and missed the formula for calculating this. Thanks for sharing. Mr. Isaac Fame, please, sir, do upload this video for future reference. It's YouTube. Once I'm done with the live stream, it will be uploaded and you can check my live videos, and anytime you can make reference to it. Then Mr. Richard, thanks for your response, sir. I really appreciate. Thank you. Now, Mr. Orin's Concepts, you joined late. What I am talking about here today is load analysis table. In my next broadcast, my next live stream, I will be taking them step by step. The next one, I'll be showing you how to size the various components of a solar power system. We'll start with the battery bank. After the battery bank, we move to the solar panels. From the solar panels, we move to the charge controller. From the charge controller, we move to the inverter. From the inverter, we move to breakers. I have a video that I uploaded on Saturday or so on how to size breakers. So you can check my channel. I have a video on that. You can learn how to size breakers from there, fuses and other OCPDs, overcurrent protection devices. And we move to cables, how to size cables, how to commission a system, safety, the safety tips you need when installing a solar power system. So I'll be taking it step by step. So Mr. What's his name? Mr. Concepts, sorry, Orin's Concepts. This is a load analysis table. And for you to prepare a load analysis table, you need, these are the rows and the columns. The first row, we have the serial number, the description, quantity, power, total power, runtime, and total energy consumption. So here you write down the appliances, the loads you are going to use the solar power system to, power. So the first one, we have television, and we said this television, there are 2 in number, and their power rating is 50 watts each. So their total power will be 50 multiplied by 2 to give us 100 watts. Now, how many hours are we going to use these 2 television per day? We say we are using them for 5 hours. So we need to calculate their daily energy consumption, because this will help us in sizing the battery bank and the solar panels. So for you to calculate their total daily energy consumption, you multiply the total power by the runtime. So what you'll be having is 500 watts hour. You follow other loads. Then when you're through, you need only these 2 columns, total power and total energy consumption. So you sum up this column. This is what we have, 145 watts. We sum up this one, we have 695 watts hour. So this one, we'll use it to size our inverter. That is the total power. And this, the total energy consumption, we will use it to size our battery bank and our solar panels. So thanks for joining my live broadcast. We'll continue in my next broadcast how to size the battery bank. Thanks for your questions. Thanks for your feedback. I'm very happy that all of us are growing together. We are sharing our knowledge together, and we are exchanging ideas together so that we can make the world a better place. We can make our environment green. We need green energy. We need renewable energy because of climate change, global warming. The effects, they are visible. We are seeing the effects of climate change. So we have to mitigate those effects. We have to, in our own way, as young men, as young women, if we know how to properly size this thing, because the demand is high, the demand is growing every day, both in developed and developing countries. So we need people that will be able to service these systems. We need people that will be able to service them. So for you to service and to install these systems, you need a good knowledge about them, a good background, a good foundation about them. So that is what I'm trying to do in my own little way. So thanks for joining my live broadcast. Please, if you have further questions, check my WhatsApp link and the description of my channel description. Check the WhatsApp link, click that link so that you can, send me a message, and by the grace of God, I will respond to your message. And Mr. Gideon says, can you please make a video on the checklist that you have to do after you have installed the solar power system? Okay, by the grace of God, I will try and do a video on that. So thank you all for joining my live broadcast. Remain blessed. May God bless you all. Thanks for sharing thanks for your time, and thanks for also your kind audience. See you in my next live stream. Remain blessed. You go wait, man, finish now.